Okay, so this is the checkpoints. So checkpoints basically try to save during the training if we want to later use it. Okay, after the training. So this is the monitoring. So basically we are saying that the during training try to save the validation loss of the training. Okay, so the model will try to save this. Okay, so after that this is the auto control dot compile. So basically this what basically this basically there is two main functions. This is the first one is MSC, this is the loss, and the other is optimizer. These are very two important things. Okay, the loss is basically the loss function which is trying to minimize by the during training. Okay, so this is mean scale error. So what is the loss we are trying to define over here? We are trying to say that try to minimize the difference between the predicted value as well as the value which was ground truth. So basically ground truth is the RGB colored image. Okay, so this is the difference between both two is the mean scale error. So the amount, the mean scale error, the how much amount mean scale error will be less, it is better to have a good image at the output. Okay, so this is the atom optimizer. This try to optimize the model during training. Okay, so this is the callbacks we are trying to define this, and then this is the function which is trying to perform the training. Okay, so this is the autoencoder dot fit. So what we are trying to give it, we are trying to give it the X train gray. This is the input data set, and this is the output of that similar data set. Okay, then this is the validation data, this is the input, this is the output. Okay, so and then we are trying to define the epochs 15 over here. So it means that the 15 of for 15 epochs the model will try to run the 50,000 images over the training 15 times. So basically every epoch we try to learn the 50,000 images conversion. Okay, so that this is the batch size, then this is the callback. After that this is the here this is the part where after that the model will be learned. So after the autoencoder, the learned model will be saved in the this autoencoder variable. Okay, after that this is after here the model is trained. Okay, so this line is the line where you have to you can change any input and you can get the output accordingly. Okay, so this is the input we are trying to give to the trained model. So this is the trained model. Okay, so trained model is trying to predict the input on the grayscale image. So this is the predicted output. So what we are trying to define this after that we have got the predicted output, and then we are getting the 100 images from that predicted output, and we try to show it over here. Okay, so see in this we have epoch 1. In epoch 1 we are basically getting 3125 batches. So it means we have defined the batch size 16. So 50,000 divided by 16, it's similar like this. Okay, and then in 15 this is the first time we the DNA is performing the training. So all the 50,000 images, then this going back to, so yeah, what is the, we are getting some loss value over here and some validation loss. So this is the learning rate. After that, so whenever the epochs increases, the loss will be reduced mean after in every epoch. For example, in epoch 4 the loss is 0.0086, then the this is 0.0082. So similarly after 15 epochs we will get a good loss less value, so that the output will be a good image. So we are showing this image. So if you see that the input image of color grayscale image is very good colorized. Okay, so this way, so we are getting very good output from grayscale image. So this is the results of the our training. Okay, thank you.